All right, guys, this is the answer video to your geometry semester exam review part 1 from semester 1. So we're going back a little bit and reviewing what we did the first half of the year. All right, number 1, fill in the blanks. The intersection of two non-collinear rays at a common endpoint is known as, so non-collinear means they're not in the same line. So you'd have one, and then you'd have another one going in a different direction, and they share a common endpoint. So this is known as an angle. When two non-collinear rays meet up at a common endpoint. A blank is a location. It has neither shape nor size. That's a point. A flat surface made up of points that extends infinitely in all directions is a plane. A flat surface is a plane. Blank lines are two distinct coplanar lines that do not intersect. Those are parallel lines. Okay, number 2, determine which of the following statements are true if triangle CAT is congruent to triangle LUV. This is not multiple choice. We have to circle all the ones that are true, okay? So don't forget that whenever we write congruency statements, there's a reason for the order of the letters, right? So here, point C and point L are corresponding. So if these two triangles are congruent, this guy and this guy are congruent. CA would be congruent to LU. AT is congruent to UV, right? Point A and point U are corresponding. Point T and point V are corresponding. So look at the order of the letters. Angles C and L are congruent. C is the first letter, L is the first letter, so that is true. B, CA is congruent to VU. CA is the first two letters, LU is the first two letters, not VU. So that is not true. CA is congruent to LU, not VU. C, angle TCA is congruent to angle VLU. TCA would be the last letter, the first letter, the middle. So this would have to be last letter, first letter, middle, VLU, and that's what it says. So that is true. They're in the same order. D, TA is congruent to VU. TA is these last two letters backwards. VU are these last two letters backwards. So that is true. And then E, angle TAC is congruent to VUL. TAC are these three letters backwards. VUL are these three letters backwards. So this is true. So the only one here not true was part B, choice B. Okay, number 3, explain how to prove the two triangles are congruent using side, angle, side. So given D is the midpoint of BC, okay? When it's set up like this, you do not have to write a proof, but to me, that's the easiest way to organize our thoughts. So we're gonna give our statements and our reasons. Okay, so here, first thing we wanna say is the given. D is the midpoint. D is midpoint of BC. The reason for that is because it's given. So because it's the midpoint, then I know this guy is congruent to this guy. So I'm going to say BD is congruent to DC. BD congruent to DC. And how do I know that? Because it just said D was the midpoint of this line. So definition of midpoint says the midpoint splits a line segment up into two smaller congruent segments. So def of midpoint. Sorry if that runs off and you can't see it. Okay, so we know these two are congruent. We're using side, angle, side. We know that this is a 90-degree angle, and these two angles are supplementary. So if this is 90 and these two angles are supplementary, we know angle ADB has to be 90 degrees. So we're going to say angle ADB equals 90 degrees. And our reason is because these are a linear pair. So we'll say, we'll just say linear pair. Linear pair. So since I said this is 90, then step 4, I have to say that these two are both 90. They're congruent to each other. So angle BDA or ADB is congruent to ADC. Angle ADC. And that's because they're both 90 degrees, right? So we'll say linear pair. We could say these two are supplementary, whichever. They're equal because, I don't know, it's the same reason. We'll say linear pair again. I'm sure there's a different definition we could use, but they're equal because they're both linear. pairs and one's 90, so the other has to be 90. 5, AD is congruent to itself. Whether it's used in this triangle or this triangle, it's the same segment. So AD in this triangle is the same size as AD in this triangle. So AD congruent to AD, and our reason is because it's reflexive. And so I'm running out of room here, but our very last step now in this line, in this line, and in this line, I proved sides were congruent, angles were congruent, and sides were congruent. Side, angle, side are congruent. So step 6, I can say that my two triangles are congruent. Triangle BDA is congruent to triangle CDA. Doesn't really matter what order you say the letters in. And the reason is because of side, angle, side. That's what it told us to use. Okay, number 4. This looks like a bow tie shape. What statement will be needed to prove that the triangle JKL is congruent to M in L using angle, side, angle? Okay, well, this guy is congruent to this guy. We know that. We know since they're vertical angles that this guy is congruent to this guy. So what statement do we still need? We can't assume anything else. We need to know something. It has to tell us a missing piece. So for angle, side, angle, not side, angle, side, for angle, side, angle, we have an angle, we have a side, we would need to know the next angle here. We couldn't say this angle because then it would be side, angle, angle, or angle, angle, side. And we want angle, side, angle. So here's an angle, here's a side, we need this angle, and here's an angle, here's a side, we need this angle. So we would need to say that angle J is congruent to angle M in order for these two triangles to be congruent for side, angle, side, angle. Number 5, which postulate or theorem can be used to prove the following congruent? Write a congruent statement for each pair of triangles. This is not multiple choice. All right, so what does it show us here? Let me zoom in a little bit. For part A. All right, it shows us that these lines are parallel, these lines are parallel. So if these guys are parallel, cut by a transversal, ignore the top and the bottom for a second. Ignore those. Just look at these two with the transversal. That tells us that this angle and this angle, the measure from our transversal to this side and our transversal to this side, are congruent. That's alternate interior angles, right? And then also, if these top and bottom are congruent, ignore the sides for a second. If the top and the bottom, not congruent, but if the top and the bottom are parallel, then the measure from this transversal to the top should be the same as the measure from the transversal to the bottom, right? So for both of these, that's the alternate exterior angle theorem. Alternate, what am I trying to say? Alternate interior angle theorem. Interior angle theorem. It asks which postulate or theorem can be used to prove the following triangles congruent. That's one of them. And then we need to use this middle side, this guy right here. What would we say? TS is congruent to itself. That's reflexive. So what have we proven now? These aren't really answering the question. What have we proven? An angle, a side, and an angle congruent to an angle, a side, and an angle. That's ASA. So our postulate or theorem to prove these two guys are congruent is ASA. And we use these along the way to help us get there. But ASA is the answer. Okay, part B. Okay, these two sides are congruent. These sides are congruent, right? And the last thing we know is that this line FJ is congruent to itself whether we use it in this triangle or this guy. So we can mark it 1, 2, 3. So all three sides of this triangle are congruent to all three sides of this triangle. So we know the triangles are congruent because of the side, side, side theorem. Okay, and then lastly, we've got this sideways bow tie here. We know with any bow tie shape that the vertical angles are congruent. That's not assuming anything. That's a fact, right? When you have two straight lines that intersect, they create vertical angles that are congruent. So that's side, angle, side, congruent to side, angle, side. So we know these two triangles are congruent because of the side, angle, side postulate or theorem. Okay, next page. All right, number 6. Which postulate or theorem can be used to prove that line A is parallel to line B? Select all that apply. All right, I want to back up and see this whole thing. All right, so if 1 and 2 are congruent, we have alternate interior angles. 1 and 2 are congruent. No. Are they alternate interior angles? No, they're a linear pair, right? So that one's not true. 2 and 3 are alternate interior angles. 2 and 3 are not alternate interior angles. Remember, interior angles are in between the parallel lines. So 2 is not in between the parallel lines. It's like a tunnel here. If the angles are inside that tunnel, then they're interior angles. That's not the case here, so that one's not true. 1 and 3 are supplementary. 1 and 3. Do 1 and 3 look like together they add up to 180? No. They're corresponding angles, which means they're the same size. So that is not true. 1 and 4 are supplementary angles. 1 and 4. Well, that is true, right? 1 and 4 are supplementary. Does that tell me that these lines are parallel? Yeah, it could, because 1 and 3 are corresponding, so they're the same size. 3 and 4 are a linear pair. So if 1 and 3 are the same and 3 and 4 are a linear pair, then 1 and 4 would be equal to a linear pair, which is supplementary. Linear pair adds up to 180. So this one is true. These lines would have to be parallel for that to be true. And then 1 and 3 are corresponding. Are 1 and 3 corresponding? They are. Does that prove that the lines are parallel? Could I have two lines that look like this with a transversal, and angle 1 could be here and angle 3 could be here, and they're corresponding? Yes. Does that mean that this line is parallel to this line? No, it doesn't. So while this is a true statement, it does not help us prove that A and B are parallel, and you have to read that in the direction. So the only one that works here is that 1 and 4 are supplementary. They have to be supplementary for these two to be parallel. All right, number 7. In the drawing below, identify the following. Alternate interior angles. So alternate interior are between the two lines. Alternate are on opposite sides. So 2 and 7 or 6 and 3. 2 and 7 are on different sides of the transversal. 6 and 3 are on different sides. So we'll say angle 2 and 7 and angle 3 and 6. Okay, alternate exterior angles. So exterior are outside the tunnel, not inside the tunnel, but outside. So here's my transversal. So 1 is on the opposite side of 6, right? Or on, it's, what is this? 8, sorry, not 6, 8. 1 and 8 are on different sides of the transversal outside the tunnel. So they're alternate exterior. And then 5 and 4, same thing. They're on different sides of the transversal outside the parallel lines. Angle 4 and 5. Part C, consecutive interior angles. Remember, they're right next to each other. They can reach out and high five each other. So 2 and 3 and 6 and 7. Angles 2 and 3, angles 6 and 7 are interior in the tunnel, and they're next to each other, same side, consecutive. D, corresponding angles. So we're going to have 4 sets of these, right? If we draw a little window around each intersection of lines, we have 4 window panes now, right? So in this window pane, we have a 1, and the corresponding window pane, we have a 3. So angles 1 and 3. This guy's the top right window pane, and this guy's the top right window pane, so 5 and 7. Okay, then we've got 2 and 4. Angles 2 and 4, they're in the same position, bottom left of each like little window pane. And then that leaves 6 and 8. Okay, hopefully you guys remember that from a long time ago when we went over it. Number 8, fill in the missing reasons for the proof. All right, so we've got our picture here and we've got our proof written out. BC is congruent to ED, that's already marked. BD is congruent to EC, that's already marked. CD is congruent to DC. It's the same line segment here. So when you say a line segment is congruent to itself, whether you're using it here or here, that's reflexive, the reflexive property. And so it's congruent. Triangle BCD, the top, is congruent to triangle EDC, the bottom. How do we know they're congruent? Because all 3 sides here are congruent to all 3 sides here. So that's because of side, side, side. And then once we know that the triangles are congruent, anything after that, any corresponding parts are also congruent because corresponding parts of congruent triangles are congruent, or CPCTC. Remember that a long time ago? Once we prove the triangles are congruent, anything after that is because of CPCTC. Next page, moving right along. Number 9, determine whether each statement below is true or false. This is not multiple choice. Parallel lines meet at exactly one point. No, they do not. They never meet. B, an angle bisector creates two congruent angles. Yeah, if we have one big angle and a line bisects it, we're going to create two smaller angles. So that is true. Put a check mark by it. C, corresponding parts of congruent triangles are congruent. Yes, it's literally one of our statements, right? Or sorry, our reasons, our rules. Supplemental angles have a sum of 90. No, complementary angles have a sum of 90. Supplementary angles have a sum of 180. The altitude from the base of an isosceles triangle creates two 90-degree angles. Okay, here's an isosceles triangle. This guy's congruent to this guy. The altitude is the height, and it's always perpendicular to the base, right? So yes, it's going to be 90 degrees. The altitude from the base of an isosceles triangle creates two 90-degree angles. Yes, that is true. So B, C, and E are true. 10, identify the constructions shown. This is not multiple choice. Remember when we went over briefly constructions and we had the, the compass that we used, and you put the one tip on your points here? Right, this is what we start with, and any of these curved lines are created by your compass. So we measure out, I don't have my compass in front of me. There's a stick and it stays in place, and then you can move out the line that has the marking point, and you move it out a certain degree, it doesn't matter how much, and you start marking, right? So we put the tip here, we marked, we left that the same measure, put the tip here, marked. Same thing down here, put the tip here, marked, kept it the same measure, put the tip here, marked, right? So these points of intersection right here, once we draw a line through them, this line created by these two endpoints cuts this line in half. So this is a segment bisector. It's just saying that when you start with these two endpoints and you use a certain angle measure and you keep it consistent the whole time, wherever those markings intersect, that's exactly halfway in between these 2 points, right? This endpoint is exactly halfway. So when you connect them, this line bisects this guy. Okay, for here, we have this point right here. So we take our compass, we move it out a certain degree, doesn't matter how much, and we draw a circle. That creates this point and this point where this circle mark intersects my angle. Okay, on each of those points, we keep that compass out the same measure, and we make a marking here, and we make a marking here, right? And where those two markings intersect, we put a dot. Now, what do we do with that dot? That dot is halfway between our angle, right? If we connect this dot to our vertex of our angle and draw a line through those 2 points, this is a angle bisector. So, angle bisector. Okay, for constructions, you will not have to make any construction. If you have questions on constructions, they will be showing you pictures, and you have to explain what the picture is in construction of. Okay, here we've got this angle, we've got this angle, and we've got this little circular marking, And what this is showing is basically, I know this is hard to tell, but that we have two congruent angles. Two congruent angles. This measure is the same as this measure. Points G to F and K to I, these lines right here are the same, right? So these are congruent angles. It's just showing you a picture of congruent angles. It's kind of a tough one. I hope you don't have one like that on your UOC. I doubt you will. All right, here, isosceles triangle. The one shown is placed on a coordinate plane with the y-axis as its altitude. So this is the y-axis right here in the middle. Find the length of AB, this entire guy. If this is the altitude and this is an isosceles triangle, then this altitude cuts the base in half. So this is congruent to this. Find the length of AB if the coordinates of A are at negative 3.2, comma 0. So you start here and you have to go back 3.2 and up 0. So the distance here is 3.2 units. We went back, so it's negative, but how many units is it? 3.2. So if this is congruent to this, then to get to B, we'd have to go forward 3.2 and up 0. So this is also 3.2 units. So what's the total length of line AB if this half is 3.2 and this half is 3.2? 6.4 units, right? 6.4 units equals AB. Okay, questions? Let me know. We got one more page here. We're almost done with part 1. All right, number 12. We have a rectangle here. Given rectangle DEFG, so we can apply all the rules of rectangles. Determine which statements are true. This is not multiple choice. DE and GF are equal. DE, GF. Is it true that this side's congruent to this side? Yes, in a rectangle, opposite sides are parallel and congruent, so yes, that is true. B, EF and DG are congruent. EF and DG are congruent. Yep, exact same reason. Opposite sides are congruent and parallel. True. FL is congruent to EL. FL is congruent to EL. Yes, because diagonals of a rectangle are congruent and they bisect each other, right? This diagonal cuts this one in half, so this is congruent to this. And this diagonal cuts this one in half, so this is congruent to this, right? I should mark these different. 2, 3, 4, 2, 3, 4, because they're not congruent to these sides. Okay, so since all of these 4, since this is congruent to this, if this was 10 and this was 10, and this got bisected, it'd be 5 and 5, and this got bisected, it would be 5 and 5. So both of these would be the same length. So this is true. Part D, triangle DLG. DLG is this guy. Would be congruent to, it would have to be ELF, this guy. Is that what it says? Yes, it does, so that is true. Triangle DEG, which is this DEG, this whole half, this right triangle half here. Let's see if we can do it this way. This guy is congruent to FLG. FLG is just this guy right here. This whole entire top half is not congruent to just this little piece. It would have to be congruent to this whole EFG, not FLG. So this is not true. This is false. And then part F, DGF is a right angle. DGF, yes, all 4 corners of a rectangle are 90 degrees. So this corner right here, DGF, has to be 90 degrees. That is true. Last question for this form. Explain how to prove that triangle MNP is congruent to ABC. Okay, so it already shows us here. This is actually a shortcut, and it was one of those rules that we didn't spend a lot of time on. But remember, whenever you have 2 right triangles, there's a rule that you can use to prove them congruent called the hypotenuse-leg rule. Or I think it's like the hypotenuse-leg theorem or something. And it just says that when you have both triangles have a 90-degree angle, if the hypotenuse of each triangle is congruent and one leg of each triangle are congruent, then both triangles are congruent. So it's the hypotenuse-leg rule. One leg and hypotenuse of each right, has to be a right triangle, are congruent. Okay, let me know if you have questions.